Hello, I saw your question here. You asked about how to find the critical values in this part here. To find the critical values, it's a two-tailed test. You can see that by not equal to, and alpha is 0.03. So I just, easiest way to find the critical values is perhaps a stat crunch. Go to stat calculators and choose the normal calculator, and you click on between since it's a two-tailed test. Leave the mean, since z-test, leave the mean and the standard deviation of 0 and 1. Then you need to give this area here, which is going to be 1 minus alpha, which is 0.93. So the area in red is 0.93. You put that area in here and you click compute, and it gives you the two critical values that you're asking about. It's a two-tailed test, and that's why I click on between instead of standard. And then it always gives you area between, which is 1 minus alpha. The area out in the tails is the 0.07. Total area under the curve is 1. So you put that area in, click compute, and you're given the two critical values. Now, how do you determine whether to reject it or not? Well, you're given alpha. Now, I don't see the part, but you got to find the test statistic z, and then from it you can get p. I'd probably just use the calculator here, find the test statistic and p at the same time. And if p is less than alpha, then we reject it, null hypothesis, which must be the case here. If p is greater than alpha, we're failed to reject it. So yeah, I guess so. It was rejected here. Then at the 7% level, there's enough evidence to support the claim. Yeah, and that's what you say when you reject it. So when you reject a null hypothesis, then you're supporting a claim, which is an alternative hypothesis. I hope this helps.